Hello, we're going to talk about rules of exponents today. The first one we're going to start out with is our negative exponent rule. So if you have a negative exponent, it can be created into a fraction. So it'll go to the opposite side of the fraction and the exponent becomes positive. So this is technically x to the negative n. You could imagine over 1. So we flip that to the bottom of the fraction, make the exponent positive, and a 1 just goes on top. If, however, we start with a negative exponent in the denominator of a fraction, it can be flipped up to the numerator and become positive. So here's an example. If we have 3 to the negative 2, to make that positive, it becomes 1 over 3 to the positive second. Then we can simplify 3 squared to be 1/9. Okay, similarly, using the second part of this rule, if we have 1 over 5 to the negative third, that becomes positive when it goes to the numerator, and then 5 cubed is 125. So I want you guys to find 2 to the negative fifth. All right, our second exponent rule would be the product rule. So that is when we are finding the product of two bases. So we have x to the m times x to the n. That becomes x to the m plus n. So when there's multiplication, our exponents become an addition problem. So a to the fourth times a squared would become a to the sixth. M cubed times m to the fifth is m to the eighth. The important part is that every single time these bases have matched. So the bases must be the same in order to add the exponents. So here's an example with two different variables. We can still simplify, but we can only simplify the like variables. So we would combine x cubed and x squared to get x to the fifth. And then remember, no exponent means there's a 1 there. So y to the first, y to the fourth would become y to the fifth. I'd like you guys to simplify this one. Okay, here's another one that incorporates our negative exponent rule as well. So we have some negative exponents. What I like to do is just treat those as subtractions. So our product rule just told us that we have to add our exponents on with like bases. So if one of them's negative, we just subtract. So we would have these two x's. So 2 minus 5 is negative 3. And then negative 3 plus 5 is 2. And then that's a 1. So we have x to the third. And then our y becomes a y to the first and a y to the negative fourth. So 1 minus 4 gives us y to the negative third. So we have x cubed y to the negative third, but our final answer should never have negative exponents. So we follow our negative exponent rule from the beginning, and that goes to the denominator, leaving us with x cubed over y cubed. Okay, here's a little bit lengthier example. So again, we can only combine things with like variables. Whenever you have a fraction, always simplify the top first and then the bottom. So combining things, I always like to do my x's first. X to the fourth, x to the negative 10th becomes an x to the negative 6th. And then our y's, 1 minus 3 is negative 2. And then negative 2 plus 5 would become a positive 3. So our numerator simplifies to x to the negative 6y cubed. Denominator, our x's would be a negative 1. Our y's would be a positive 4. Okay, so then I make both of those positive. So we have x to the first and then x to the sixth. So these two just flip-flop. Our y's don't need to move since they're both positive. But in order to combine our x's, we need to move, I always just move these to the top to make it easier. So we would have x to the first, x to the negative 6th. That y cubed is going to stay, but then we have to bring this y to the fourth up, which makes it negative. Now we can combine our x's. 1 minus 6 is a negative 5. 3 minus 4 is a negative 1. Then both of those are negative, so they both need to go to the denominator of a fraction. So we have 1 over x to the fifth and then y to the first. Remember, you don't need that first power. Okay, one more rule. We have the power rule. So we have x to the m raised to the n power. We multiply these two exponents. So there's a couple examples. If you have more than one thing inside your parentheses, both variables or all variables or numbers get that exponent. So a to the 6th b cubed. Okay, here's an example. Again, simplify the numerator, then the denominator. So x to the negative 6th, that y stays the same. Sorry, that's crooked. X to the negative 3rd, and then y to the positive 6 on top. The denominator becomes x to the 6th, y to the negative 3rd stays, and then an x to the 6th. Now we're here, we need to simplify, so we have a 1 minus 6, which is a negative 5, minus 3 more, x to the negative 8th, y to the 7th on top. The denominator is x to the 12th, y to the negative 3rd. Okay, make your exponents positive, so we bring that x to the 8th down and the y cubed up. So we have y to the 7th, y cubed on the numerator, x to the 8th, x to the 12th on the denominator, leaving us with y to the 10th on the numerator, x to the 20th on the bottom. And then I would like you guys to simplify this problem.